Two absolute titans of the crypto world. We're talking trillions of dollars in value with entire digital economies being built on top of them. But here's the thing, these two giants have a fundamental, kinda hidden problem. They literally can't talk to each other. It's like there's a digital wall separating them into two completely different universes. So why is that? Why can't these two powerhouses just communicate? It seems like a massive oversight, right? But what's really fascinating here is that this isn't some accident or a flaw. It was actually a deliberate choice. Let's break down exactly why. To really get this, we need to rewind the clock and look at what each of these blockchains was actually built to do. See, they exist on opposite sides of this huge digital divide, and it all comes down to their completely different goals. The easiest way to think about it is like this. Bitcoin is basically digital gold, while Ethereum is more like a decentralized world computer. Bitcoin was designed from day one to do one thing and do it perfectly, be an ultra-secure digital currency and a store of value. And to make it as secure as possible, its programming ability is super limited on purpose. Ethereum, on the other hand, was built to be this flexible playground for developers to create, well, almost anything, from DeFi to games. It's a supercomputer, not just a currency. So you end up with these two revolutionary systems that speak different languages, they follow different rule books, and they have totally different blueprints. Their separation wasn't a bug that needed fixing, it was a core feature. It allowed each one to become the best at what it does. But this separation also creates a massive problem, a fragmented digital world. So if these worlds are separate by design, how in the world do you move value and information between them? How do you connect these isolated digital islands? Well, engineers came up with a pretty ingenious solution. They decided to build a bridge. Now, the fancy technical term for this is cross-chain interoperability, but don't let the jargon scare you. All it really means is that it's the tech that finally lets different blockchains talk to each other, to send messages, move assets around, and share data. This is what turns a bunch of separate networks into a truly interconnected ecosystem, which is what people are really talking about when they say Web3. So, how does this digital bridge actually work? Let's walk through the most common method, which is called lock and mint. It's a pretty clever three-step process. First, step 1, lock. A user takes an asset, let's say some ETH on Ethereum, and locks it up in a special smart contract. Then comes step 2, mint. The bridge sees that the ETH is locked, and it creates an equivalent wrapped token on the other chain. Think of this wrapped token like a claim check or an IOU. And finally, step 3, release. When you want your original ETH back, you just burn that wrapped token, and the bridge unlocks your original funds. It's a brilliant trick to make it feel like your money just teleported from one chain to another. Problem solved, right? The bridges are built, the digital economies are connected, everyone's happy. Well, not so fast. Because while these bridges are unbelievably powerful, they've also created one of the single biggest security nightmares in all of crypto. $2 billion. That's the absolutely staggering amount of money that has been stolen from cross-chain bridges just since 2020. This makes these bridges the #1 biggest target for hackers in the entire world of decentralized finance. It's not even close. So why are these bridges such a honeypot for criminals? This quote right here really nails it. You see, unlike a truly decentralized blockchain that's secured by thousands of computers all over the world, many of these bridges create a central point of failure. They collect hundreds of millions, sometimes billions of dollars worth of assets into one single smart contract, a giant digital vault. And that vault becomes this irresistible all-you-can-steal buffet for hackers. Okay, so how are these hackers actually pulling this off? Well, their methods usually fall into one of 3 main buckets. They exploit simple bugs in the code, they steal the private keys that control the bridge, or they do something really wild and hijack the very infrastructure of the internet itself. Let's take a quick look at each one. First up, flawed code. At the end of the day, smart contracts are just computer programs, and programs can have bugs. The Nomad Bridge hack is a crazy example of this. A tiny error in a software update basically allowed anyone to approve their own withdrawals. It turned into a total free-for-all. Attackers literally just had to copy-paste a successful transaction, swap in their own address, and boom, the money was theirs. Almost $200 million just vanished in a matter of hours. This second major attack is just good old-fashioned theft. Stolen keys. The Ronin Bridge, which was vital for the popular game Axie Infinity, was secured by a group of just 9 validators. 9! That meant an attacker only needed to get control of a majority, just 5 of them, to sign off on any transaction they wanted. And through a really sophisticated phishing attack, that's exactly what happened. Hackers got control of 5 keys and just walked away with over $600 million. It's a perfect and terrifying example of how the security of a massive financial system can end up resting on just a handful of keys.
Now, this last one is really fascinating because it has nothing to do with smart contracts or stolen keys. BGP hijacking is an attack on the internet's core routing system. You can kind of think of it as the internet's GPS. Hackers can basically lie to the internet and falsely announce that they control the web traffic for a bridge's website. This lets them redirect you, an unsuspecting user, to a perfect copy of the real site. So you think you're depositing your funds into the secure bridge, but you're actually sending them directly into the hacker's wallet.
So after hearing all that, billions stolen through buggy code, stolen keys, even attacks on the internet itself, it's fair to ask a pretty critical question. What does the future of a connected blockchain world actually look like? Are we basically stuck choosing between these isolated networks that are safe but don't talk to each other and these super vulnerable bridges that connect them? Is a truly secure and interconnected Web3 even possible? Well, the good news is the industry is hyper-focused on solving this exact problem. The way forward is all about learning from these painful attacks to build much more resilient bridges. This means designing systems with way more decentralized validation, so you don't have those single points of failure. And it also means implementing incredibly rigorous code audits and security checks to make sure these bridges are rock solid before they ever go live with real money. And that really brings us to the ultimate takeaway here. For all the hype about building the next big blockchain or creating new digital worlds, maybe the single biggest challenge facing this entire industry is just figuring out how to safely and securely connect the incredible worlds we've already built. Because solving that problem, that's the real key to unlocking the full potential of a decentralized future.